Hello and welcome back to RC Model Reviews. Today I'm taking a look at the RMILEC. Is that what it is? RMILEC UHF Long Range System. RMILEC. There we go. I've taken it out of the box to save you all that waiting. And let's have a look at what was in that box. So here's what I found when I opened up the box. This little collection of goodies here. Now, we've got this antenna. This is an articulated antenna, which means it has two joints in it. So you can have it straight like this, like the old long wire, or you can actually move this little collar up a bit. On here it says little collar. You can move that collar up to one of the two joints, and then you can put it up at an angle like that if you want to, so that it goes at right angles. Now, yeah, telescopic antenna, it's okay. It'll probably work. I've heard some people say they're not very good. And at first I thought, oh no, surely they're not going to be hanging this huge, heavy antenna with this tiny little SMA connector on the back of the module. And I was right. Fortunately, they're not, because it comes with this extra lead here, this extension lead, which simply screws onto the base here. There we go. And this unscrews from there. Gosh, it's actually, yeah, she's a pretty, I'd rate this antenna 4 out of 10. Not the best thing I've seen. And then this lead here, of course, just screws onto the back of the module like so. Hence, we can then use these plates which they provide. Lovely little plates. I'll take them out of the bag so you can see them in all their glory and detail. A couple little plates. This obviously mounts on the handle of your radio, bolts through like that, and then I guess this little connector bolts through that hole. But again, you've got a big heavy antenna poised, balancing off this little SMA connector. Oh, I'm not so fussed about that. I mean, this is quite heavy. It would be nice if they had a nice light antenna instead of this massive weight. And this is what I'm talking about. This antenna, if I just set it to 0, whoops, crappy scales. This antenna weighs 49 grams. 49 grams, that's about 2 ounces. This one, here, this is a whippy one. This one here weighs in at 38 grams. So it's quite a bit lighter, and it's more flexible because this doesn't flex. So any stress you put on the end of this is going to be translated directly onto that tiny little SMA connector. It's going to stress that. Oh, I'm not happy with that. I'd much rather see an antenna like this. So when you put stress on the end, it just bends, and very little of that stress is transferred through to the base. But we're testing what we were given when we bought the product, and yes, we had to pay full price for it. It wasn't a freebie. So I paid full price for it. So I'm going to test it out as it comes, and I'll let you know if this connection here is a bit of a hassle, but I think we might be buying a newer antenna, or making an antenna for it perhaps, so we avoid all this massive weight on the and the leverage that we get from this. But back to the kitbits that we got when we bought the product. Now, as I say, we've got the module there. I'll take this lead off because we're not using it at the moment. The module, it's quite a heavy module because it's a reasonable power output. I forget what they are, a watt or something, maybe 2 watts, I don't know, I can't remember. So yeah, there's going to be a bit of metal in there, heat sinking and so forth. It's only plastic on the back, so I have a concern it may get a bit warm if we don't do something, but we'll test it, see how it goes. Got the receiver. And this is It's an 8-channel receiver, which is fine because if you're converting an existing long wire set with one of these modules, 8 channels is all you get most of the time anyway. It has antenna or receiver diversity. I don't know. We'll have a look inside the receiver and see which it is. Notice how long the antennas are. Now, you've seen this type of antenna with the 2.4 gig receivers have these sort of coaxes with the long extension in a wire there, which is a quarter wavelength of the thing. So you can see that UHF is a much longer wavelength than 2.4, so you have to have much bigger antennas. Now it comes with these plastic tubes as well, if you're wondering what these are. These plastic tubes, in theory, enable you to route this wire. I'm old, I can't even push wires in holes anymore. Here we go, route these antennas and keep them pointed in the right direction, because you want them in a nice V shape with a 90-degree angle between them to make up the effects of cross-polarization and so forth and give you that full diversity. Now obviously if you tried to do that just with the antennas, they'd be all floppy and they'd blow around in the wind, they'd all trail at the back of the model. So these plastic tubes here provide you with a nice rigid, although these ones have got curved and packing, so hopefully they'll straighten out. I might use a bit of heat gun on them, get them straight again, so that when you put them on your model, they're not going to get blown around as the wind passes over them. Nice and simple. I noticed also somewhere, yes, it comes with a bind plug. There we go. So I haven't looked at the instructions yet. No printed manual, just go online to get the documentation. I didn't get a printed manual at all, so if I didn't have an internet connection, I'd be stuffed. Never mind. No disc or anything like that either, so there you go. So that's the kit of bits that you get with your RMILEC. Why don't they just call it Acme or Fred or Bob or something so we can actually pronounce it. Anyway, that's the kit of bits you get. Now I'm going to convert my JR9X2, which to you in America is a 9303, I think, 9305, 9302, something like that. You'll recognise it when you see it. I'm going to convert that transmitter to the RMILEC system, and we're going to put it in the ARC. No, we're going to put it in, what is it? That penguin thing. Yeah, that's right, the penguin thing with the ARC bird or ARC pilot or whatever it is. On-screen display return to launch system. So let's get started on that. First of all, convert the transmitter. So here's my JR transmitter. Currently it's got the FreeSky module in the back, which I use for FPV. That's good for, 2.5, 3.5 kilometers just with the standard antenna. No problems at all. It is the telemetry version, so it gives me beeps and things if I'm getting out of range. And I've been using this in the Hobby King EPP model with the FY21 AP. But now I'm going to take out the FreeSky module. I'm going to put in the RMILEC one. Let's see how hard that is. Oh man, I might have to take the antenna off first because the aerial gets, the handle gets in the way on this. And there we go. So now I have unfreeskyed it. See how well the module fits in, because that's quite important. Sometimes the plastics on these things, not so flash. Where are we? Wrong way. Upside down, upside down. Here we go. That's nice and snug. Seems to go in very nicely. Now again, important thing, don't turn it on without the antenna connected. Same with all this radio frequency stuff. Even these, you shouldn't run them without an antenna on, because as I mentioned in my video on video transmitters, the power that got nowhere to go goes back inside. And if you're talking in a watt or more, then that's more than enough power to quickly heat up the insides and cook them. So don't run it without the antenna on. Now we've got a set of plates here which I have to obviously bolt on. I might have to break out the manual, but I don't know. Let's see how I go, because I don't know. Yeah, that would probably work like that. I'll do some bolting. And they do provide the bolts actually. Look, see? Get a little bag of bolts. Isn't that lovely? Let's bolt that thing on and see what happens. So there you go. She's all done. As you can see, I've put the cable in. I've mounted this on the handle. Hopefully the handle's strong enough to handle that extra stress. I know something like an Eclipse 7, these handles break off real easy, so I'd be a bit careful about putting too much strain on the handle. I'm not sure the plastic looks strong enough in these, but this is like wobble, 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 wobble city, because of this articulated joint thing here that's supposed to be, it's just, nah. I mean, look at it. If I, see, look at this. Woo. That doesn't instill great confidence, does it? No, it doesn't. Never mind. Enough griping about the antenna. I think it might be time to put this thing on the spectrum analyzer and see what it does. Righto, let's bind this up, and I have to bind it up before I test the output, because who knows what handshaking goes on between the receiver and the transmitter. Let's see what we do. It says, A, install the receiver and other electronic devices. I've done that. Turn on all electronic equipment, short jumper 1 and power up the receiver. Let's do that. Jumper 1 is shorted, receiver is powered up. The little red light is currently flashing. I don't know if you can see that on the video. Then it says hold down the utility button and turn on the transmitter. So holding down the utility button, turning on the transmitter, and wait for the voice of 4Bs. What does that mean? Oh, there we go, 4Bs. Remove jumper and power cycle all systems. So do it in the sequence suggested. And power off. Now, transmitter usually goes on first, doesn't it? Turn on. Oh, it made little noises. Here we go. Now, what does it do? We have a red light. I better plug a servo in and see if it's working. Here is a servo I prepared previously. I think this one works. It's a Hobby King. It must work. The reason I had to get the manual out was because there's no indication on the receiver which way up the servo connectors go, and there's no keyway in here for the Futaba type connector, so I figured, well, who knows which way it goes, but negative goes to the top. Apparently, I'll plug this in. Here we go. It seems to be energized. It should be, which channel? There we go, ailerons. So it does seem to be working. I should have put an arm on the servo, but that's close enough. Yeah, all seems smooth enough. That was pretty painless. Right, so now let's get this the spectrum analyzer out and see what it all looks like. Okay, let's take a look at what this thing looks like on the spectrum analyzer. Now, I will turn on the transmitter, turn on the receiver, and away we go. There we go, look at that. Ooh, it's hopping around. As you can see, it's hopping quite aggressively there. 3 channels by the look of it. I'll just change the setting so that I go to maximum. We'll be able to see the channels as they appear. There we go. 3 channels. So it's hopping on 3 channels. Just to make sure that I'm getting the big picture, what I'm going to do is expand out. So I'll go to my span and I'll increase the span. At the moment is 20 megahertz from one side to the other. I'll wind that up. Here we go. Now we're at 200 megahertz. So we're going from about 250 megahertz up to 650 megahertz. You can see it's just in the middle there. I'll wind it down to 100 megahertz. So you can see we've only got 3 channels being used and they're quite closely spaced. I can measure those channels. I can tell you what their spacing is by going to my marker. Now you're learning how to use a spectrum analyzer here, so it's a great value video. You see the little triangle moving there as it's going up the slope. When I get up to here, I can measure the frequency at 433.76 and the next peak is at 434.56 and the next peak is at, here we go, 435.60. So those are the frequencies it's operating on. Only 3 channels. That's a bit disappointing, really. And the total spread is, well, work it out. I can't be bothered pressing the buttons, but obviously it's not using very much. Of course, the 433 meg band is quite small, but it says on the back of the transmitter module that it covers quite a wide range, and I'll show you what that range is later. But there we go. That's it. Now, one of the things a lot of people have complained about is that the RMILEC is a dirty transmitter, a noisy transmitter. Now, here we have our, let's go back to that center frequency. It's transmitting 434.64. Now, if I can find my calculator, because I'm old and my brain doesn't work very good for math anymore, I shall multiply that by 2. So 434.64 times 2. The second harmonic, which is basically if you double those frequencies, it should be 869.28. So let's change our frequency, go up to 8, up here, 869, and see what we find there. Here we go, 840, 850, 860, 870. Look at that. Look, there is the second harmonic of this transmitter. And it's quite normal to get some output at that sort of second harmonic frequency, but it should normally be way down. You have filters in the transmitters designed to suppress those harmonics. But look, it's nearly as strong as the original signal. That's terrible. Now, obviously, we're not using anything else on the model at 860 megahertz. But what if we go back? I'll just work out what the third harmonic is. Multiply by 3 equals 1.3039 gigahertz. Let's change our frequency again. Let's go up to 1.3 gigahertz and see if we've got a third harmonic there, because this is getting pretty close to our video frequencies. 1.3. Look, there is the third harmonic, and it's still really high. There's amazingly high output way up into there. So if you've got a video transmitter, let's see what the exact frequencies are there. Just go to my marker, move my little triangle so I can measure what that bottom, there we go, that's actually 1.3012, so that's very close to 1.2 gigahertz, 1280 gigahertz, the 1.3 gig video gear some people are using. So if you're using that, the RMILEC system is very close to that frequency. What it means is that your transmitter will stomp all over your video receiver because it's putting out such a huge signal, even at 3 times the intended frequency. That is bad. That's very, very bad. I'm not at all impressed with that setup. So yeah, it's not going to affect me on 5.8 gigahertz, which is what I use for video, but if I was using a 1.2 or 1.3 gigahertz video transmitter, it could cause me some real grief. There are ways around that, of course. We could put an external low-pass filter on the transmitter, and that would certainly make things a whole lot easier. But why should you have to pay extra for something that should be part of it? And because the case of the module is plastic, we'll still get some second and third harmonic output, even if we put a filter on the lead that goes to the transmitter antenna. Not really that impressed actually. Okay, let's take a look inside the transmitter module, and it seems to be held together by a series of Phillips headed screws in the back, which are done up very tightly. Can't complain about that. Don't want it falling apart, do you? I noticed when this module, when I had on the bench here, it actually got quite warm, just with a little bit of, you know, the 10 minutes of testing I was doing. So you probably need to be a bit cautious about the use of this thing in very hot weather. They make note in respect to the receiver being limited in temperatures. Don't use it with high voltage in hot weather. But the transmitter, probably the same. Now here we go, this is what you get inside. Let's have a look here. Oh, it has its name on it, isn't that nice? Little buzzer. I guess I have to take some more boards apart here. These are soldered together. Dang, why did they do that? Now looking inside this thing, I can see there's actually 3 circuit boards. As you can see, we've got this top one here, there's another little daughter board in here, and then there's the one on the back here. This one seems to contain all the radio frequency stuff, and there seems to be some heat conductive compound here, some white compound. Why? I don't know, because this appears to be plastic. So trying to heat sink it to plastic, even though it's ribbed, I don't think it's going to make a whole lot of difference, although it does get warm, as I said. Construction seems reasonably good. As I say, not a lot to gripe about. It's okay. It hasn't dazzled me with its brilliance, but it's all right. Little pads up here, probably for in-circuit programming once they've built it. A little buzzer here that makes the beeping noise. And yeah, what else can you say? I'd like to have seen them use a metal backplate on here though, because this heat thing, I'm not sure about that. I might just keep a temperature probe on here when I'm using it, just see how hot this gets, because plastic doesn't conduct heat very well. So if this is getting warm, it's getting very hot inside. So unfortunately our summer is over, so I won't be able to test it. Well, hopefully I won't be able to test it to destruction by flying it for a long time in very hot conditions. So maybe anyone that's used these in the summer heat can let us know if this becomes a problem. You could put a little fan on here, I suppose, if you wanted to, but as I say, this is plastic. It's not going to make a lot of difference because it doesn't conduct heat very well. Now I was going to pull the receiver apart, but it's been quite cunningly put together. It looks like this actually slides in from the front, the aerials poke out there, and then it clicks into place, and I haven't actually worked out exactly how to pull it out yet. I'll have a bit of a play, but time is short today, so I might just get this video out as I don't expect to find any major surprises inside the receiver. It'll be pretty standard stuff, I think. But there we go. Right, so there we have it. Moves the spectrum analyzer to the side. This transmitter's still on, and I've got to tell you that's probably 60, 65 degrees C on that module on the back there. That is, really, 70 degrees C, I'd say. That is actually very, very hot. And I've only had it on for what, 10 minutes? Turn it off. Electronics don't like running that hot. And so this needs attention. And this is on the low power. I've got it set to low power, not high power. I think on high power, that's going to run unacceptably hot. So whether it's because this aerial is perhaps crap and not properly tuned, I don't know, but not good, not good. So let's do a bit of summing up on part 1 of the review of the RMILEC system. What have we found? Well, we've found that it goes into the transmitter pretty easily. The antenna's crap. It wobbles, it shakes, and so I'm not impressed with that. But you can buy ones on eBay for 433 megs that will do the job much better, and they look whoopee like the one on my spectrum analyzer there. Okay, simple as. We've had a look inside the module. We found it's reasonably well constructed. It's pretty optimistic, and as I mentioned, because this is a plastic backplate, I'm pretty sure it's plastic. Maybe it is, I'm sure it's plastic. So the fact that I can't hold my finger on the back of that probably means that the circuitry inside is running really hot. And if it runs too hot, then it's going to stop working. And if it stops working when you're 20 kilometers from home, well, hopefully your return to launch system will bring you back, but it may not. You may not have RTL, so who knows? So yeah, from that point of view, I hate to think what it would do on full power. The receiver, it seems to work. It seems to be reasonably smooth. It was easy to bind. The whole system only uses 3 individual frequencies. Apparently it selects them at bind time, which I think it's a bit like DSM2 really. DSM2 used 2 frequencies it selected at bind time. We actually selected it power up. This, I'm not sure, it seemed to say in the instructions that the binding process established the frequencies, which means that if you bind your system one day when there's a whole lot of noise on one part of the band, and then you come and fly again without rebinding and that noise has moved to the part of the band you're using, then you're in trouble. And that could explain why some people have had a few problems with this, from what I've read on the internet. Some people find that when they're flying, they don't get very good results at all, very short range and a lot of fail-safes and low RSSI. That may be because they're flying in areas where there is a lot of noise. And there's a lot of stuff makes noise. Your keychain fob for your alarm, for your car, for your house. These things make noise. Even the little burglar alarm sensors I've got in here, the passive infrared, a lot of those run on 433 megs. They emit regular little chirps of noise. So yeah, only having 3 frequencies to choose from makes this a bit of a risk. It actually says on the back here, I'll get my granny glasses because I hate being old and not being able to read the fine print, which means I never sign contracts. Although it was only operating on around 433, it says here it operates on 400 to 470 megahertz. Well, there was no sign of that much spread when I did this, and I did rebind it several times, hoping that maybe it was something I'd done wrong, but no. And of course, you don't want it operating on that entire spread because it's outside the ISM band. You'll get in trouble. You get told off because, in fact, the legality of this thing is a bit questionable anyway at the power levels it runs. If it just chooses those arbitrary frequencies, you can guarantee you're breaking the law somehow because you're not supposed to run high levels of power on 433, and it is a pretty small band, so if it did run on 400 or 470, someone's going to be in trouble. It's probably you if you're using it. Something to think about, something to consider. Now, I think there's probably ham band allocations. I haven't checked. Probably can run a ham band allocation in there, but I don't know what the power levels are. And you may have to hop on more than 3 frequencies. I don't know, to get any reasonable amount of, or the right to use any reasonable amount of power. So those are things you have to look at. And because UHF does travel a lot further than things like the 5.8 gigahertz video signal, then you have to make sure that you're not causing problems to other people, or they will hunt you down and take your radio away. You don't want that. Remember, keep it legal, keep it safe if you can. Otherwise, make sure you don't annoy people. Right, so yeah, those are the things we've covered. I'll now put it in the fin-wing Penguin, and we'll do some flying, see how it works in the air. We've got an industrial area over here, and we've got some a big factory, big plant, timber plant down the road, and the city's just a couple of 3 kilometres away. So I'm going to make sure the fail-safe is properly set because I have a feeling that, based on what I've seen here, this system, the RMILEC, may not be as resilient as I would like. And I also will be very careful because it splatters all over the band. It's knocking the hell out of 866 megs and 1.3 gigahertz. So yeah, it's built to a price, you might say, but we'll try it out and see how it goes. So thank you for watching. If you've got any technical questions or any questions at all, just put them on the bottom of the video. If you like the video, give it a thumbs up. And if you want to see part 2, don't forget to subscribe if you're not already a subscriber. Part 2 could be rather exciting based on what I've seen here today. Thank you for watching. See you again very soon on RC Model Reviews.